Hello everyone. Today we are going to study about Moore's voting algorithm. What this algorithm is used for is to find out the majority element of an array. So, let's check out a question on LeetCode. So, here we have a question called majority element, question number 169. The question says, given an array nums of size n, return the majority element. We have been given an array nums and we need to return a majority element from this. So first we need to find out what is a majority element. So majority element is the element that appears more than n by 2 times. So any element that is going to come more than half of the times in an array is what we call majority element. Okay, so here we are assuming that it already exists. So let's say we have an example over here which says 3, 2 and 3. So the size of the array here is going to be 0, 1 and 2. So this is the array index. So size of the array is going to be 3. So n by 2 would be like 1 and 1.5, but we will take it as 1. So it should have more than one element. If it has more than if any element that comes more than one time, then it is going to be a majority element. Hence here the answer is 3. Now here we have another example. The size of the array here is 1, 2, 3, 4, 5, 6, 7. So the size of the array is 7 here. So the majority element should come 4 times or more than 4 times. Okay, it is basic maths calculations, right? So how we can basically find out this? The simple brute force approach would be, we would just loop over this array and we would count the frequencies of each and every element. So we would need 2 loops here. For one is for I and one is for j, and then we would compare and we will add the count. If the number is same, means if both the numbers are same, then plus the count. We can find out like this. But what happens in this approach is that it is going to take n raised to 2, order of n raised to 2, means n square time complexity. But we cannot accept n square time complexity here. So what we are going to do is, basically we are going to use a very optimized approach in this case, which is Moore's voting algorithm. So we can see here it takes order of n times. How it is going to take? Let's read about this. So the main logic behind this is, it cancels out the non-majority elements. The element which is not coming in majority, it cancel outs. Cancel outs means simply reduce the count of it, so that we do not need to store the count of this and also the majority element. Okay, and believes that the count is always going to return a positive number if there is a majority element. If there exists any majority element, then it is always, the count is always going to be a positive number. So how it does this is, we'll get back to this again in the later part. So here we have how it starts is, basically the current element. We have taken 2 variables, current and count. The current shows the majority element we are considering right now. Okay, and the count is the frequency of it. So here we can see we have initialized count as 1 and current as nums of 0. So count will be 1 initially. Okay, so now let's see. Here we have the first element is means the first element is 2, means the current is set to 2 and the count is 1, because this is already initialized here, right? Now we'll move to the next element, means here the incrementer moves the I to the next index. Hence the index here would be 1. In this situation the count is going to be plus. Why? Because here we have a condition. Simply here we have used a for loop which will run from I equals to 1 to nums of size, means till the end of the array. Okay, so nums of I is equals to current. Now we need to check this. nums of I means nums is this array is called nums here. Nums of I means I is pointing to the 2, means this element is equals to current. Is this condition true? 2 is equals to 2, right? This is correct condition, right? Hence it will go here and the count will be plus plus, hence we can increase the count to 2. Now we will move the incrementer to 1, and hence the else part will not be executed as if is already executed in this situation. And here we have this else condition. How it is executing, let's check out. So the next element is 1, means the nums of I is 1 while the current is still pointing to the 2, means both are different. In this situation it will go in the else block, as both are not same. It is going to reduce the count, means count is going to minus minus and 1. Now it is going to check if count is equals to 0, count is 0, no 0. So let's skip it for now. Okay, so now incrementer again increments the value of I. So here the nums of I is 1 while the current element is 2. This is not true, right? Both are not equal, hence count is again set to 0. The count is 0, and if count is equals to 0, in that situation what we have to do, if count is equals to 0, then current is equals to nums of I. Set the current as nums of I, hence our current element here was 1 and count equals to 1. Count again equals to 1, means count of 1 is 1. Now it moves to the next part. Here we have this 1 again. So nums of I is equals to current, right? Hence the count will be incremented, and then it will move to 2. So nums of I is different from the current, hence count will be decremented. Now again the nums of I is different from hence the nums of I here is 2 and the current is 1. Both are different, hence the count will be 0. And as the count will be 0, the current element means nums of I, this is going to be set here, and count is going to be 1, means this element at the end is going to be like this. What basically we are getting in this is that this current variable is basically going to show us our majority element, means anything which is remained till the end in this is going to be our majority element. Okay, so simply we are returning our current here because it is showing us majority element. So we can see we have just used a simple for loop here, hence the time complexity is order of n, and we did not use any auxiliary space, hence the space complexity is order of 1, and this all was completed in a single pass. So one thing we need to assure here is that it will work properly only if the majority element exists. So if the majority element exists, only in that condition it will work. So any question that does not state that majority element will properly work or not, in that situation we need some of those conditions to check out if majority element works is there or not. So in that situation we will need some of the checks. Now let's try and execute this question here. We have already coded it here, we can check this, and this all that you can see here, all the test cases are passed, and see it beats 100% and analyze complexity. So as I said earlier, the time complexity is order of n, hence we can see the solution here. And that's all from my side. Now you can see this code. If you want, you can take some screenshots and read it again later, and you can read this too. So that's all from my side. Thank you. Have a good day.